Hi guys, I hope you are doing well. Welcome, welcome to my channel. My name is Shazan Arifin. At this moment, I'm finishing my PhD from RMIT University, Melbourne, Australia. So I'm launching this channel for various purposes and for sharing my knowledge uh, I gathered throughout my studies, beginning from my Bachelor of Engineering, then Master of Engineering, then the PhD. I used to learn a lot of things from my research supervisors, and I used to learn how to write a research proposal. I used to learn how to write a thesis, how to conduct the research, how to prepare the professional CV and resume, how to design microgrid by using different software tools and platforms. And I used to learn how to conduct the power system analysis in off-grid and grid connected platform of microgrid for solar wind hybrid energy systems and other renewable resources as well. So today I'm just giving the introduction of my channel and of my future plan, what I'm going to do. I will start today with a small microgrid design through the HOMER Pro. I hope you already learned how to design the microgrid through the HOMER Pro. So I will give the basics of HOMER Pro. This is the first lesson I'm going to give you. I will continue on the latter part as well. For next week, I will come back again with part 2 and with more interesting designing tools through the HOMER Pro. Through the other sources as well. I will start with PV today, PV and diesel generator. Then I will switch for wind, diesel converter and other things as well. You can use the PV for both DC and AC. So it's the application of converter and inverter in between the AC to DC buses. So what I'm going to do, let me explain what actually I'm going to cover in my sessions. So this is the first session. This is the introduction section. So I will cover in near future and my near videos how to write a professional CV and resume to convince the research supervisors. You often face some difficulties in writing the professional CV and resume to apply for a research degree for master by research or PhD and to convince the supervisors. I'm here in Australia, so I know the system in Australia. I will explain that one in brief for future videos. Then I will cover how to write a research proposal, because for applying any kind of PhD or master by research degree, you have to prepare and you have to submit the research proposal. Then I will cover how to prepare a research article to be published in a renowned journal. So whatever you conduct the research throughout your research through the by research master's degree or PhD, you have to publish 1 or 2 articles to fulfill the requirements of your degree. Then I will cover how to conduct the research supervisors, how to email, and what types of things you have to include in your email to convince the research supervisors. I will cover that on as well in near future, near videos. Then I will talk about how to secure a scholarship for PhD. So what types of things and what criteria you have to fulfill to secure a scholarship in any Australian universities. I will explain that one in near future in next videos. Then I will cover how to find a suitable research university in Australia. So I will try to cover all the universities in Australia and whoever offering the research degree and offering the scholarship as well, and the deadlines of scholarship and admission applications. I will try to cover all of them. Then finally, I will start the professional designing, how to design a microgrid by using various simulation softwares and techniques. Then I will cover with the how to conduct the power system analysis in terms of microgrid operation and planning. So I will try to cover all of them, and in near future, if I feel some more things, some more fields need to be covered, I will add that one as well. So here is the introduction. So let's start with a simple design by using HOMER Pro. So if you just search through the Google, you will have plenty of materials of written HOMER or HOMER website, which is explaining some things like that. Here is a manual just explaining the photovoltaic PV array, how to use it, and in between what will be the interfacing. So here mentioning about the inverters, then the MPPT, then the advanced inputs, and many more things explained in brief. So today what I'm going to do, I'll give you some ideas throughout the practical operation. So here is explaining about the source space to limit the boundary of the simulation, optimal sizes. Here is the number of solar panels, number of wind turbines, and other things, and also the capital cost, replacement cost, operation and maintenance cost, and other things as well to produce the cost curves. So let me explain through the HOMER Pro. So what I'm going to do, here is a address bar and the options to choose the loads, components, resources, project, and the help button. So what I'm going to do, at first I need to choose a component. So today, this session, I'm going to explain with PV. So let's start with the PV module. So here is already given you three options: generic flat plate PV, concentrating PV, super vario track VTPV. So you can have the option to choose more from the library function. So I'm clicking here at the library. So from the components list, I'm clicking on PV. So have a look, plenty of PV module is giving you the option to choose. It's all are rated, and the information regarding this one is a commercial one, so you can find out the info of this kind of PV panels quite easily. For the learning purpose, I'm just giving you the option for choosing the generic flat plate PV. So I think you know already what the flat plate PV is. It's already explaining it which type of PV array you can choose. So I'm just using the flat plate PV for this analysis. So I've selected this one. So let me explain at first the expenses, the cost of PV array. So when you choose one of them, the HOMER Pro will give you the option to change the capital and the replacement cost, as well as the operation and maintenance cost. So when you choose any of them as capacity of 1 kilowatt and choosing this one as well, so it will give you the cost automatically. So what you have to do, you have to search through the Google for the PV panel prices in your area per kilowatt. For in your area, in your energy market, what is the current price of the PV array? So you have to put the capital price here, and the replacement, I think you can get the rebate of 5% or 10%. So if I choose this one as 2000, that will be better. And as well as the operation and maintenance cost. The operation and maintenance cost for the PV panel per kilowatt cannot be $10. It should be less than that. So you can get it $2 per kilowatt. So then what you can do, this is the lifetime of a PV array, it's 25 years. That's the manufacturing, it depends on the manufacturers. So then more options here to get the rebate. You know what is the rebate is. If you choose the more item, that means item 2, that means 2 kilowatt size, then you can choose more of them, or you can wait for the HOMER optimizer. Here is the option for HOMER optimizer and the search space. To search space to give the boundary to choose the actual size according to the load profile. So what I'm going to do, I'm just clicking on the multiplier. That means if you choose more of them, so you can give it to 5 max for this analysis, or you can simply leave it as one of them, only one for the particular analysis. Then what you can do, you can increase the price, the operation and maintenance cost, and the replacement cost. So for the replacement, you can choose the rebate as 0.4. Usually any energy market will give you the rebate price at 0.1. And when you're using this one also give you the option for choosing the multiple operations. Anyway, so if you choose this one as a multiplier, it will give you the option for choosing different one as the sensitivity analysis. To open the portfolio for the sensitivity analysis after the optimization, you must have declared the rebate for the price and multiplier as well for optimal sizes and the operation and maintenance cost and replacement cost. Anyway, so if you choose the HOMER optimizer at first, HOMER will give you the idea what will be the size can be, but this is not exact value. This is not the correct one. So after getting the first analysis from HOMER optimizer, you will have the idea. Then you can click on search space and you can give your own size, what you actually require. Okay, so let's choose a generator for this analysis. For this analysis, if we choose a auto size genset, then I think most of the size will be taken for this one. Or you can simply choose your size according to the design. If I choose the generic small size generator, so we have given already a generator. So what will happen? We can fix the size from here. If I choose 1 kilowatt, and for this one as well, you can give the lifetime. You can increase the lifetime as well. You can select the maximum runtime as well. You can add the CHP heat recovery rate as well, and the minimum load ratio as well. And the diesel fuel price, which is very important, you have to choose the diesel fuel price according to your area. So you have to find out this one, and you can convert it to USD, and you can analyze this according to USD or according to your currency. So for this perspective as well as you can get the rebate as well. So if we get 0.6, that means 60% rebate. So what will happen? You can select this price as well according to your demand, according to your load requirement. Then have a look. We selected the DC PV array. If you select the AC, then only AC bus will appear. So look at this on the left hand side is asking for a load and for a solar GSI, global horizontal irradiance resource. So what I'm going to do, I'm just selecting the solar GSI. So what I can do, either I can download from internet, that means the resource will come through from the NASA solar meteorology data, NASA surface meteorology and solar energy database. So for GSI, the 20-year period, that means 1983 to 2005, this database already taken by HOMER, NREL, the developer of HOMER Pro. They collected it and they selected it and they saved it for the HOMER Pro database. So if you download this one, it will come through. Then the temperature option, you can do it same. So before selecting this one, I need to tell you a very interesting thing. So which area you have to choose for the meteorological data? You have to choose the area. Suppose you are selecting a island. Suppose I am choosing this for Phillip Island. Phillip Island is an area in Melbourne in Victoria, Australia. So Phillip Island, if I search location search, if I click on the location search, it will give you the exact location where in Australia. Then what you need to do, you have to download the radiation, solar radiation and temperature data again. Then it's replaced, and from the NASA database, you have find out this one. You can do it this one as well, or you can simply import from a time series data. You can download it from, you can buy it from the meteorological department of your area, and a single column data in a txt file. So I'm showing you how can it looks like. So it looks like a txt file and a single column, solar radiation or wind speed or temperature for a 24-hour for a year. So if you have this data, you can import and edit, and you can simply import and click import and edit, and you can find out from the folder you saved your file for the solar radiation. Or you can simply use the HOMER one, the NREL one, the NASA surface meteorology one. So you have got this one as well. So now you're asking to add a load. So for load, you must have your own load, because the load profile mentioning here in HOMER Pro is absolutely for the particular area, suburb of USA. So use USA based. So you can have a look on the right hand side. The database has load data for the location within the US. If you are modeling a project US, your location will be matched to a US location of similar climate. So you have to have your own load profile. So what you can do, how can you collect that solar data? You can collect this solar data from your meter reader, from your energy provider, or simply you can calculate by per unit calculation. That means the number of electrical appliances you are using, like televisions, like computer, like refrigerator, like lights, fans, and other things as well, like water heater, water geyser, and plenty of things. So you can calculate. I think you have already learned from the basics of the electrical engineering how to calculate the load profile, how to calculate the per unit from the given from the given electrical appliances. So I'm not going through that one. So you can calculate, and you can save in a txt file, and you can import from here, or you can ask your energy provider, or for a particular area you can buy from the energy provider or energy department to collect that load profile data. For this one, I'm just importing and editing. So I'm clicked on the import and edit. I have my own load profile, so I'm importing it from the inbox inside my computer. So before proceeding, I need to select as linear load profile, and I'm filling it, and I'm just pressing OK. So the load profile is came through. You can have a look. Is a AC load is connected already here, and the scaled annual average is given 3.26. So I have already taken the temperature as a resource, the solar GSI. I have already selected the diesel generator and the load. So it's ready to select the calculation to calculate the optimal sizing and the techno-economic analysis. So what I'm going to do, I'm just clicking on the calculate. So let's see, it's giving that HOMER was unable to find a system which meets the load demand. That means here some reasons you're given through. Not enough generation capacity, not enough annual capacity shortage allowed, emissions limitations, minimum renewable fraction. So if you get this kind of error, what you need to do? You need to go back and you need to increase the generation. So suppose you taken as 1 kilowatt of solar panel, you can increase it by giving the surface space. So your average peak is 1.79, so at least to 3 kilowatt. Then let's see what happened. Again, we are finding that HOMER unable to find the system which meets the load demand. So if you get this kind of error, what you can do, you can increase or you can select the capacity shortage constraints. So look at this, the constraints giving you the option maximum annual capacity shortage is 0%, so it cannot be 0%. If you select it as 10%, then look at this, what happening. I'm running again, and this time giving the result. Have a look, is choosing the HOMER cycle charging. So I will explain you on my next session about the optimal sizing dispatch strategies. So for this analysis is choosing HOMER cycle charging, but you'll have plenty of options on the top hand side, right hand side, microgrid controller. So you will have 4 of them, and in fact 6 of them. 4 of them is very popular, and I will explain in brief on the later sessions about the dispatch strategy in HOMER. So from the results, what we are getting, this is the summary. So you can browse through the tables and you can have a look at the techno-economic analysis. So from the compare economics, it will give you the comparison in between the modules. From the electrical part, you will have the option, you can have a look. The 40% is coming from solar panel, and almost 60% is coming from the diesel generator. So what you can do, and 65% is excess electricity. So what you can do, you can reduce the capacity shortage, and you can tune it by decreasing the diesel generator. So what we can do, if we remove the diesel generator part, let's see what is happening. We are getting nothing. That means it's totally dependent on the solar part because we removed the diesel generator part. So let's increase the solar size by giving more. So if we choose 6 kilowatt hour, what will be 6 kilowatt of size is showing that is not enough yet. So if we increase more of them, then what you can see, we can increase it to 8 kilowatt. Then let's see what is happening. Still not good. That means it's still not meeting the load demand. So why it is not meeting the load demand, we can find out from the solar radiation availability. Look at this, have a look. From April to September, we are getting very less solar radiation. That's why it's unable to find out the combination, the feasible combination of solar panel for this part. So I think for meeting this load demand, you can add a wind turbine, or you can add a generation as diesel generator. So if we choose the auto size genset, so what will happen, we can have a look. Definitely it's gonna be minimized. Yes, it's minimized. So that means what we came to know, that PV alone cannot fulfill the load demand of 3.26 kilowatt hour per day because of the availability of the solar radiation. So I think you got the idea, enough idea to design any small microgrid from HOMER Pro. I will explain many things about the wind turbine and the other parts, and as well as how to minimize the cost, how to select the right kind of PV array, and how to select the surface space in my next sessions, as well as I will explain the dispatch strategies as well. So please subscribe me and just press the bell icon to get more videos. Hopefully see you next time with more interesting videos of microgrid designing and the professional research outlining and more interesting discussions. Till then, have a good time. Bye.